Hey everybody, welcome back. This video will give you a walkthrough of the basics of Python for data analytics. This is intended for you if you have not had any experience or have only little experience with Python for data analytics. If you have taken my other course, BZAN 6355, then you probably don't need this. However, if it's been a while since you have taken that course and you would like to have a little bit of warm-up or refreshing your mind, then I highly suggest that you watch this. Also, if you have been using Python for other purposes, such as gaming development, I also recommend that you watch this video before the beginning of the semester for this course, because Python is a huge programming language. It is a platform for many use cases, and data analytics is just one of them. For the purpose of this tutorial, I'm going to use Jupyter Notebook as the programming environment, as you will do for this course in the semester. Alright, let's get into it. To begin off, I will launch Jupyter Notebook. I am doing this tutorial on a Windows laptop, so the experience of doing this on a Mac will be slightly different. First, I'm going to bring up the command prompt for Windows by using the Windows and R key combination. Windows key plus the R key. I get this, and it remembers my previous operation, but if it's blank for you or it's something different, just type in cmd command and you should get command window. I've already got it down below, so I'm going to cancel this, and you are going to click OK or hit enter key. You should be able to get a window like this. If you have been following my course tutorial on how to install Python and the Jupyter Notebook programming environment, as well as the other packages, you should be able to do this. To bring up the Jupyter Notebook, just type Jupyter Notebook. Keep in mind that it's Jupyter with Y, not the planet of the solar system, Jupiter. Here it's Jupiter with Y. Click enter here. The Jupyter Notebook window should appear shortly. I'm going to resize the window a little bit. I'm going to open this blank Jupyter Notebook to do my tutorial. The first thing I'm going to demo is about Python packages, how to install them, how to upgrade them, etc. I'm going to create a few cells here just to make it easier. Alright, so the first thing that you will do after you create a new Jupyter Notebook is to import the packages that you are going to be using. So typically we will import these packages as they are dispensable for doing any of the operations, any of the activities in this course. Import numpy as np, import pandas as pd. Also import sometimes the library. Oops, there's a typo here. You can see that it's a typo because it's not having the same color theme as other keywords. After correcting that, the color theme is correct. I also import matplotlib .py.
'plot' as. 'Py'. 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 'plot' as. '
type log. Okay, go ahead and run it. It's successful. These packages have been imported with these aliases. I can use these aliases to refer to them. Sometimes you want to use a package that you haven't installed, and what should I do with that? Now I'm going to demonstrate what you can do quickly to resolve that issues. First of all, I'm going to need a package that I haven't installed. Because I have installed everything that's needed for the course, I cannot use one of the things that you will be using. So I'm going to have to use something that we are not going to use, but I'm using it for the purpose of demonstrating the errors that I get when I import something that I haven't installed, as well as how to install it. Now I'm going to use PyTest. It's a real package, but I haven't used it. And I'm going to demonstrate how to install it. Now let me say that again, you are not going to need this package. I'm using this package as demonstration here because it's an alternative to the scenarios that you will run into. Alright, let me run this. I get an error. It's not successful. And the error says that no module named PyTest. Obviously I haven't installed it. So now I need to install it. There are two ways to do the installation. Alright. Method 1. Within the Jupyter Notebook. So you type in the commands that you would use, that which you learned in the tutorials for the course, where you installed and set up the Python programming environment. These commands, you do them in the command prompt inside the Windows or terminal on Mac machines. Here I'm going to run those commands inside the Jupyter Notebook. pip install this new package for me. So let's see what happens. It's not running because it does not. So I'm going to try one more time here. It runs successfully. And let's observe the log here. It says successfully built, successfully installed all the dependencies of this package, and this command is successful. Now the reason that this command wasn't successful above it is because I have other Python languages here. In order for this to run in the Windows command prompt environment, it cannot have any other languages or syntaxes. Once it detects other languages such as Python, it's recognizing that it is no longer valid syntax for Windows prompt. Therefore, you need to keep only the Windows prompt commands here. So this is successful. Now, installing a package doesn't mean that you can use it immediately inside the Jupyter Notebook. In order to use any installed Python packages in a specific Jupyter Notebook session, you need to import it. So after installation is successful, you need to import the package. If I import PyTest, it's successful. Now you can use it. Alright, great. So this is a convenient way of doing it without exiting the Jupyter Notebook. Another way to install a package and make use of it in Jupyter Notebook is to install it outside the Jupyter Notebook with the default method of installing packages in the Windows command prompt. What you want to do what you want to do is to open another command prompt, because here the command prompt is monitoring the Python session, the Jupyter Notebook session. Therefore, it cannot be interrupted. So what you want to do is to get another command prompt by using Windows and R key combination. Click OK, and you will bring in another of the window and do the installation. You can do pip install pytest. Now obviously it's not going to do it because it had already installed it just now. If I click that, it's going to say requirement already satisfied. It didn't do it, but the package has already been installed. Now, if it's not the case, if it's a case that you are installing the package for the first time outside Jupyter Notebook, in the command prompt, it will go through the installation process and tell you that installation is successful. But then after that, you can close this. Of course, don't close that. This is monitoring the ongoing Jupyter Notebook session. After that, you will have to save your current notebook and save any of the ongoing notebook that you're working on. Save them, exit, close it. The best way to close it is to go to the file and close and halt. Once you click that, this window will darken and say, now you can safely close this window. After closing this tab entirely, go back to the menu of the Jupyter Notebook and open this notebook again. Run from the beginning. Then you can import this one successfully. Alright, I hope that's being helpful, and let's move on. One last word about packages. Now sometimes as you work on Python throughout the semester, some of the packages that you have installed have already been upgraded, the same as with your Windows or iPhone systems gets upgrades over time. So when that happens, you want to upgrade your version of the package up to date. Here I'm going to demonstrate the command that you will use to upgrade that, and keep in mind that you also have two ways to do that. One inside the Jupyter Notebook, the other outside Jupyter Notebook in command prompt, just as I demonstrated earlier. So let's try upgrade the pandas package. Note that pandas package has not been upgraded since I previously did so not long ago. So when I do this, it's going to skip that, but it will say, no need to upgrade. So the command to do that is this: pip install. Instead of typing the package here, you will need to type double dash, two dash together, and without including any space, also include a keyword, upgrade. So double dash upgrade, then space followed by the package name, pandas, and run this. And let's see what it says. It says requirement already satisfied, which means there's no need to do that. Okay, so that's all about packages. Next up, I'm going to talk a little bit about the basics of using Jupyter Notebook, this interface, Jupyter Notebook. Now, I'm not going to talk about details, but I'm going to refer you to a video . The homework assist video is for the course BZAN 6357. It is the homework assistant video for the basics of using Jupyter Notebook. And over there, I did a tutorial and walkthrough of the basics of using Drupal Notebook, just like this video here, but that one is focused on the Drupal Notebook itself. I'll include the link down below in the description of YouTube, and I also include the link to that video above the video on Blackboard Canvas. Next up, I'm going to talk about the basic data formats of this course: data frames as well as series. Data frame is the basic building block of the data set that we are going to be using over and over in this course. And embedded in data frame, there are series, and I'm going to talk about the differences here. Before I begin, let's use a data set to demonstrate the concepts and methods of data frame. What I'm going to do is to import the content of a data set saved in a CSV file. As you can see here, this is my working directory for Drupal Notebook, and here there is a CSV file, mpg. I'm going to import this. And assign that data frame to df-mpg. Okay, take a look at this data frame. This is a basic view of a data frame. Throughout the semester, you will be very familiar with this because you will see different versions of this over and over for different data frames. The basic format of a data frame involves a set of columns, as in going vertical, and each of them have a set of rows, as in horizontal. So this mimics a spreadsheet that you often work with in Excel. Each of the column is what we call a variable, and for Python pandas package, each of the column of the data frame is also called a series. Therefore, this is a series, this is a series, and this is a series. This data frame has 11 series here, as in 11 columns. The other concept is a row. A row, 1 row, 2 row, 3 rows, etc. And they are 233 plus 1 row, because the first row begins with the index value of 0. So rows and columns are the basic building blocks of a data frame here. As I said, each of the columns is called series. Now it's not just a name difference, it's also a concept difference. The series bear different properties, although other similar properties with the data frame, and I'll explain that. Now you may ask, how do I access or how do I select a series of a data frame? Let's do that. Let's take the example of a year series or a year column, and let's access the year series. So what you want to do is to type out the data frame name and then use single pair of square bracket without typing anything in between, and then type out the name. Now keep in mind the name of the columns are all in string format, so you need to include that in a pair of parentheses, either in a pair of, you want to include that in a pair of quotes, either single quote or double quote. Doesn't make material difference here. I prefer single quote because I don't have to push the shift before I can type out a pair of double quotes, but it's up to you. Now, in rare cases, you have to use double quotes, but in most of the cases, you can use single quotes. I'm going to include year inside the pair of quotes, and then I'll hit enter. I'll hit run. I'll get the values that are in the year series. As you can see, the values correspond to each other. The output format is slightly different between the series and the data frame. It's just a way that Python is showing the differences to remind you that when you see these plain values without the shades and formats, it's a series, whereas when you see these fonts and when you see these bold fonts and shades to indicate the different rows, it is a data frame. The reason is when you are showing the contents of the data frame, there are often much more data than a series. Therefore, these formats are useful to differentiate different columns and rows. It's often very useful to assign a series into something to refer to it later. So here we go. I'm going to assign something to this year, and that something is the series year, just as I did previously. When I assign it, it doesn't happen. When I assign it, nothing happens, but things happen in the background. And when I print out the year, the new object that is the series, I will get the exact same printout as before. Now that you know the differences between data frame and series, I'm going to talk a few about the basic methods and functions about the data frames and series. Every time that you read in a new data frame, it's often very useful to take a sneak peek of the rows and values and the columns of each of the data frame. So here I'm going to print the first few rows of the data frame, df and pg. When you say hand, it's going to print out by default the first 5 rows of the data frame, including all the series, which is the columns, and the first 5 rows. However, you can change the default behavior and print out instead, let's say, 3 rows. And this time I'm only printing out the first 3 rows. You can also take a look at the bottom 3 rows of the data frame by using tail. Intuitive. Next up, sometimes when the data frame is simple and when you are familiar with the values of the data frame, you did not have to print out a few rows. Instead, you only need to take a look at the different columns inside the data frame. You can do that by calling the headers df_mpg.headers. When I run, I get an error message. It says data frame object has no attribute headers. It has no attribute headers. I wonder what happened. That's right. It does not have the headers command. It doesn't have the headers attribute or method. the headers is a completely wrong keyword here. In order to get the headers, you actually want to use the columns. And be careful, there are no parentheses here. You actually cannot include the parentheses here. If you do, you'll get a message, which is error. Instead, you'll use the .columns attribute, and it's going to return an array, this is an array, similar to a list, but it's an array object. It's an array of strings which indicate the list of column headers. The same thing as you can see here. So that's how you get the column labels. Remember, it's not headers, it's column. It's not headers, it's columns. Next up, I'd like to talk about value assignment. Sometimes I need to assign something or a portion of a data frame to something else so that I can refer to that specific portion elements later. That's actually what I did earlier with assigning a series to something else and then refer to it directly. Here, I'm going to create a mini-sized data frame here. Instead of working with 200 rows something data frame every time, because I would like to see all the elements of a small scale data frame in the following demonstrations in order to make the point clearer. So here we go. I'm going to use a method which is actually a slicing method of data frame to create a smaller scale data frame. So dfmpg.lock. I'm going to use lock as a slicing method to take the rows between 0 and 3 and to take 3 columns. I use a list, which is a pair of square brackets, to indicate a list of different items. Here, the list of different items will refer to the select list of column headers which I would like to select. The first thing I would like to select is manufacturer. The second thing I like to select is year. The third thing I like to select is the highway MPG. These will correspond to the first column, the fourth column, and the 10th column. And when I do that, I got an error message which is saying passing list likes to doc with any missing labels is no longer supported, which means there are missing labels. What does that mean, missing labels? This means that one of the labels that I provide is not included in the original list of column headers. And after further examination, I found that this has a misspelling. It should be HWY instead of HYW. If I correct that, HWY, I got the correct output. So, when you are spelling out the column headers, be extremely careful to avoid typos. That can be helped by first carefully examining the content or the structure of a new data frame before you start working with it. Alright, so this command will get a slice, the first 4 rows of the data frame and 3 of the columns. But what I would like to do is to assign it to something else. I'll name it df mini MPG. If I run this, nothing seems to be happening, but something is happening in the background. And my mini MPG is now defined. When I run it, it will show the slice of the data frame. It's another data frame. It's a smaller scale data frame here. And now it has a different name, df mini MPG. I'm going to work with this to conduct the rest of the demonstration. Now, a caution: when you assign a slice or a series or something, a subset of a data frame, never assign it back. Never do this. Never do this. Never do this. Never. The reason is, once you do that, the original data frame is lost from the memory, and there is no way to get it back unless you go back all the way up and reread the data frame. And after you do that, you will have to rerun the entire list of cells to get the point where you are ready to do the next. So never assign it back to the same data frame in the memory. Next up, I'm going to demonstrate a few about comparisons in Python data analytics. Keep in mind that when you conduct comparisons on data frames, you'll get a data frame. This is what I mean. I have the df mini MPG. If I were to compare with the value 1999, you can see the content of the mini MPG here. If I were to compare 1999, pay attention to the double equation here. Double equation means comparison, whereas single equation, single equal sign, means assignment. Alright? So when I compare the mini MPG to 1999, which is a scalar or an integer, Python is going to compare each of the column and each cell of the columns, basically each element of the data frame, to 1999, and return another data frame with the same structure, same number of rows and columns, and same headers and same row indexes, with the values of the data frame replaced with true or false of the comparison outcome. So if you were to compare each of these names of the manufacturers with 1999, obviously they are not going to be the same. They are going to all return false. Same thing with these numbers that are all smaller than 31, 32. But with the year, two of the values will return true, but the other return false. So let's take a look. If I run this command, this is the result I'm getting, exactly as I expected. So keep that in mind. When you compare a data frame with a scalar, it's going to return a same structured data frame, only with the values of the data frame replaced with the comparison values of pairwise value comparison. And the same rule will apply to series. So if I do this year, now remember that year is the long series that I created previously. It has 200 rows or so. If I compare year with 1999, it is not going to be a smaller, a miniature series, but it's going to be a long series. It's going to have 200 some rows. In order to do a meaningful demonstration here, I'm going to create a miniature series. So I'm going to create a mini year, which is the same as the series. I'm going to assign the series mini MPG year and give it and assign it to mini year. And after that, when I compare mini year with 1999, I'm going to get only 4 values here, which should be exactly the same as the column of the comparison result between the mini MPG with the value 1999. Some of you might have a question at this point. Can I compare the mini MPG data frame with the mini series? Both of them have 4 rows, right? Can I compare? If the comparison goes through, the expectation might be that for the first column, comparison between manufacturer and mini year will all return false. The comparison between, because it's essentially comparing the manufacturer series with the year series, the values should be different. But the second column should all return true because it's one-to-one correspondence between the year series and the year column of the data frame. And it should also, for the third column, it should all return false. So it should be 3 columns: true, false in the first column, true all in the second column, and false all in the third column. Let's try that. If I were to compare mini MPG with mini year, I will get this. Wait a minute, what is this? Instead of getting 4 rows and 3 columns, I get 4 rows and 7 columns. Besides the 3 columns that I recognize here, it also has additional 4 columns. Why is that? What does that mean? This means when you try to compare a data frame with a series, something wrong could happen. It could happen very often. So when you compare multi-dimensional objects, be super careful if you don't know exactly what's going to happen. Alright, so this comparison is no, not good. This comparison is not good. Next up, I'm going to talk a little bit about axes of the data frame and a few other methods of the data frame, as well as the series. Now, oftentimes, when we work with a new data frame, we need to make sure that there are no missing values in the data frame. A very useful method that we use with both data frame and series is the .isNo parentheses method. So here's how to use it on a data frame. What this method is going to do is it will examine every element of the data frame, including all the columns, series, as well as all the rows or all elements of the series, and return true if the value is missing, or else return false if the value is not missing, because it's examining whether it's null. If I run this on a mini MPG data frame, it all returns false because the values of this mini data frame are all non-missing. However, this is probably not the most efficient way to tell how many missing values are in the data frame. Imagine that when your data frame has 5,000 columns, you cannot simply visualize, and you cannot simply visually examine each and every of the rows and columns, but you want to get a summary or aggregate result of the count of missing values. the way to do that is to use an aggregate method out of the result of the isNow method. So you will do mini-mpg, call the same method to examine missing values, and then based off of this result data frame, you will do a sum. Now, this sum method by default will sum over the values of all the rows by each of the column. So the result of this sum aggregate method is that I will get 3 results, each counting the number of trues out of all the values of each of the column, because there are no trues or false, and in mathematical term, all the false will equal 0 values, and all the true will equal 1 value. So when you aggregate, false will equate 0. It goes cancel. It goes void. It goes away. Whereas if there's any true values remaining in if there's any true value, it will be added up to the sum result. So if I run this, I get 3 results. All of them are 0, meaning there are no missing values in this entire mini data frame. Well, wait a minute. Some of you might ask, what if I want to know the row sum instead of the column sum? This is doing the column sum of the missing values. What if I wanted to know the total number of missing values of each of the column? First of all, we rarely do that. The reason why is that the columns or the series are the more meaningful building blocks of the data set, whereas each of the row typically refers to a case, and whereas each of the column is made up of values of the homogeneous type. For instance, all the years are probably integers, and all the manufacturers are probably strings. The values of the rows will tend to differ, as in the first value of the row would be strings, and the second value of the row is integer, and the third value of the row is integer. So it changes. That means the values of the rows, the values of each row tend to be heterogeneous type of data, and we will not typically work with the data set row by row. Rather, we pre-process the data set by columns. But if you insist to get the aggregate number of missing values by row, here is the way to do that. Again, you get the isNow result data frame, and then call the sum method. But instead of specifying nothing inside the method, you will specify axes equal 1. What does this mean? This means to do the aggregation, to do the sum along the rows by each of the row instead of by each of the column. So after this, I'm going to get 4 results, each with 0 number of missing values, because there are no missing values here. But I'm going to get the result by each of the rows. Let's do that. I'm getting an error here, which is likely a typo. Some got an unexpected keyword, ASIX. I was intending to type axes, AXIS, not ASIX. Therefore, I need to correct the misspelling and then run the code. There you go. I get the result exactly as I expected. Now is a good time to talk about a few words of caution for Python programming in data analytics. The first one I'm going to talk about is avoid using any loop, especially the for loop, in pre-processing the data, as it will become clear in the homework assistance videos and the course modules and the coding examples that I provide for the class. You will notice that in pre-processing the data, I discourage the use of any loop, especially the for loop, because doing that is very inefficient, is counterproductive. Pandas data frames and series are designed in a way that can handle operations of the data frames as if it were enacting on each of the cells. For example, recall that I did the comparison earlier. When I compare a data frame with a single value, Python will compare each of the values of the data frame with that value. Therefore, you will not need to use a for loop to go through all the values and all the columns of the data frame in order to do the same. Therefore, quit using for loops. Even if you like it very much, quit using for loops in pre-processing data. Now, that said, for loop is indispensable for model training into the semester of the course. Therefore, you will get to use for loop a lot still, but not in data pre-processing. Keep that in mind. The second words of caution is about indexing and slicing. While you might be familiar with indexing and slicing in R programming and other programming languages, in Python, you need to know that indexing and slicing begins with 0 in Python. The beginning number is 0, which could take some getting used to at the beginning of your learning process. Let's use the data frame that we have been working on to demonstrate. I'm going to use mini MPG here. It has 4 rows, although the row number begins with 0 and ends with 3. Now, these are not actually row numbers. They don't always start from 0, but their position always begins with 0. So this is the position 0, and here this being 0 as the row index is coincidental. It could begin with something else, and it doesn't have to follow a numerical order. Just keep that in mind. But behind the scenes, the position index of the first row is 0, as well as the position index of the first column. So in order to get the first column and first row, by using the iloc, indexing notation, I'm accessing the position indexes of this data frame. So in order to get this Audi, I'm referencing the first row, the first parameter, the first variable here, row 0, row position 0, and column position 0. By this, I'll get Audi. Now, you may wonder, is this Audi that Audi I'm referring to, or is this Audi the other Audis? In order to demonstrate that, I will have to use a unique value here. Let's try to get 31 and make sure that the concepts are clear. Again, mini mpg.iloc, and this time it's on the position 0, 1, 2, row with index value 2, and column 0, 1, 2. with index value 2. I should get 31. There you go. So now you should be convinced that when I use iloc, it's using the position index. It's using the position index of the rows and columns, beginning with 0 as the first row and column. Next up, I'm going to demonstrate how to do the slicing. How to slice the first 2 rows. You can, by using position indexes, you can still use .iloc to slice the first 2 rows. I'm going to do this. Slicing the first 2 rows. Slicing by using 0, 2, 0 to 2 as the rows. And if you probably have noticed that I skipped the comma and the second variable here. By omitting the comma and the second variable, I'm telling Python that I'm going to get all the columns. I'm not going to specify any column slicing. Instead, I'm going to get everything. So give me everything that you have. And by specifying a slicing notation 0 to 2 for the rows, I'm getting 2 rows. But you may say, wait a minute, if it's between 0 to 2, 0 being the first row with index position 0, shouldn't I be getting 3, which includes 0, 1, and 2? Shouldn't I be getting 3 rows instead of 2 rows? Very good question. This is another tricky point of Python programming with indexing and slicing. The first tricky point is the one that I said. It always begins with position index 0. The other tricky point is that when you slice, it always slices until the end position that you include. So it stops until 2. It doesn't include 2. Another way to work with this more efficiently is that is how to better expect how many items that you are slicing. If you go with 0 to 2, it ends before 2 but including 0, so it will get 2 minus 0 number of rows. That's 2 rows, 0 and 1, without including position index 2. So that's another way to work with that. As another example, if I were to slice the rows with position 1 and 2, I should be using from 1 to 3. Why 3? 3 minus 1 is 2 rows. I'm getting 1 and 2. Position 1 and 2 rows. Great. Alright, one last question. What if I want to slice an entire column instead of certain rows? What if I want to index the entire column of the year here? Earlier I demonstrated by using the column indexing, which is by using the column label. What I did is, by not including anything between the square brackets, not iloc, not anything, but directly following the data frame with a pair of brackets and the column label, I got the year. The other way to doing this, the other way of achieving the same thing is by using ilocs, but this time I'm using the location here. So if I use the iloc, I'm going to have to indicate the position index of this column. The position index of this column is 1. Then I can run this, right? Not so quite. You see, if you do like this, Python is going to think that you are trying to access or slice the row with index position 1, not column. It's going to give me this row. it's going to give me this row, because the first variable, the first parameter within the square bracket is always the row. But how do I tell Python to get all the rows but specify a specific column? You will use colon. You guessed right. So you must specify colon in the first position, in the first variable within the square bracket, and then you will put the index position of the column, which is 1, in the second parameter here. So doing this will give me the exact same content here, the series for year, as you can see here. So keep in mind all the nuances here. I'd like to remind you that there is another useful video with a link included down below the YouTube video in the description or above the video in Blackboard or Canvas, which I made for another course, but of course you're welcome to use that video. Watch that video, which has better visual indicators, visual cues about how to understand indexing and slicing in Python lists and list-like objects. One last point I like to say is data frame versus NumPy arrays. As you work through this course, you will use both the data frames and arrays. Now they are quite similar, but there are differences. Data frame is a spreadsheet with 2 dimensions, rows and columns, always. It only has 2 dimensions, rows and columns, with the metadata headers and row indexes, such as these are headers, these are row indexes, and all the columns are series. Series has row indexes and object type. However, NumPy arrays can be multidimensional. It can be more than 2 dimensionals. It can be 3-dimensional, 4-dimensional, or multidimensionals. It can be much more complex. But in a 2-dimensional space, NumPy's arrays and data frames can be quite similar. But one difference is that NumPy arrays do not have the metadatas. This is what I mean. If I use the mini MPG, and then let's get the values here for comparison, and I use the mini MPG, and then I use a method to extract the arrays of this data frame. What I get are the values behind this data frame as an array. So this is an array of 2-dimensional. It has 4 rows and 3 columns, exactly as the values of this data frame. However, you notice that there are no row indexes, 0, 1, 2, 3, and there are no column headers, manufacturer, year, and highway MPG. Instead, it is a matrix, only values, only numbers. It's a matrix of things. Because of their differences, we'll leverage the advantages of the data frames when we pre-process the data, because sometimes we refer to the column names, refer to the row indexes. However, when do we use the NumPy arrays? When we train the models. When we train the models, we only refer to and work with the values of the data set that we work with. Therefore, we will not need metadatas when the models are being trained. That's the main differences. Other differences include that the NumPy arrays do not have access to the rich sets of methods as the data frames and series, and here's what I mean. Now, to demonstrate the lack of rich methods of arrays, I'll have to make the array and array object here. So I'm going to assign dfmpg the arrays behind it to the array, and then when you print that, you'll see the values of the array. And when I type the name of the array and try to access iloc, same thing as I did earlier when I tried to do the indexing. It's going to say that there's an error. What is the error? It says numpy.ndArray, which is array. NumPy.ndArray is n-dimensional array, multi-dimensional array, which means array. This array object has no attribute iloc. It has no method or function or attribute iloc. The reason I want to show the message, the error message to you, is to illustrate a point. Don't panic. When you see an error message, don't panic. Try to read and understand what the error message is saying. Let me guarantee you, after working with Python for so many years and after helping students to go from beginner to intermediate levels, 90% of the messages, especially for beginners, 90% of the error messages are because of typos. Carefully read the error message to try to locate where the typo is, and then fix the typo and run the code again. More often than not, you'll find that the error message is cleared. The codes work well. For the rest of the error messages, could be anything. It could be because there's no such method. It could be because of mistaken data type. For instance, here, the NumPy arrays do not have this method, do not have this attribute. Therefore, you cannot use that. After reading this error message, this object has no attribute iloc. If you are sure that data frames has iloc, and you're sure that iloc is not a misspelling, yes, it is not a misspelling for data frames, you do not expect this error, then that indicates that the object that you're working with probably is not a data frame, but something else. If you were to swap it with data frame, let's say mini-mpg.iloc, it should work. It works. Therefore, if you get the message, carefully think about the object that you're working with and think about why the error message occurred. And most likely, you'll start to realize, aha, it's the aha moment that you start to learn more and more about Python programming, and you are on your way from being beginner to an advanced. That is all. I hope this video has been useful. See you later.